So this is our graph. I was just looking at this, and I think that this scale is going to work. I think we can draw a line across here. Oh, the experiment number is experiment number 626. Thank you. Okay. Right, and I think we can draw a line generously above the bottom because we're not going to use all of our vertical scale. There we go. Okay, and this dimension here is going to be frequency in 10 to the 12th hertz. Right? You could say that it's terahertz, right? Yeah, isn't that what 10 to the 12th is? I believe it is, yeah? Isn't it? There we have it, right? Okay, and for that scale we are, I think what we do is we say that, I think, what is it? I think that it's 40 terahertz per square, yeah? Let's just see how that works. 1, 2, 3, 4, 5. 5 times 40 is 200, isn't that right? Yep. 1, 2, 3, 4, 5. That'd be 400. 1, 2, 3, 4, 5. That'd be 600, I think. Is that going to work? Yeah. That's going to be too small, isn't it? I thought I had this all figured out. 1, 2, 3, 4, 5. That's going to be 800. 1, 2, 3. 1, 2, 3, 4, 5. That is kind of small. Do we like small? Is small good?
Small's fine.
Do we use half of it? 36 by 48. Somehow I thought I came up with that number. Because I went 1200 divided by 48. I got 25. Piss. Shut up. Yeah. How did I get 40? All right. I'm very sorry about that. Because 25 is a lot nicer. Isn't 25 a lot nicer?
Yeah, a little bit.
Yeah, we like 25s better, don't we? Yeah. I thought I checked that too. Crap. Okay, doesn't that mean every 4 is 100?
Yes.
Yeah, that's perfect. Isn't that perfect? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 100, 200, 300, 400, 500, right? Right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? So 500, 600, 700, 800, 900. 1, 2, 3, 4. Now we're in good shape, right? There's 1,000. 1, 2, 3, 4. Yeah, I think we're good, right? We got 1,100 here. Right? There we go. Yeah? Okay. Now vertically, where'd that come from? Vertically, I think every square is a tenth. I think that works, doesn't it? Because we got to go up to 27 squares. We got considerably more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 1 volt. 1 terahertz, baby. 10 to the 12th. We should have flipped it over so our axis was over here, shouldn't we? So many things, right? So this is going up to 3.0 volts, yeah? And then this is the data That's the data that we're going to graph. Notice how nice a data table that is. Isn't that a beautiful data table?
Yeah.
Units, uncertainties, et cetera, right? Okay, so 620 is going to be 600. This is 625, so 620 is like there, right? Okay, and 0.4 is 1, 2, 3, 4, right? There's a dot. 690 is, well, there's 500, 600, 700. 690 is like here. And that's 0.7, 1, 2, 3, 4, 5, 6, 7. 740, well, there's 7, there's 725, there's 750, 740 is like solidly there. And that's 0.9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. Okay, 820. Well, there's 500, 600, 700, 800. Here is 825, so 820 is just shy of that line. Right? That's 1.3, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the question that might be occurring to you as you blindly graph this is, what is this data and what does it mean? 500, there's 1,000, this must be 900, 960, well, there's 950. Ours is not to question why, ours is just to make the freaking graph. Okay, 1.8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 1175 is the only one that falls on an actual line, right? 2.7. So here's 1. Here's 2, is that right? 0.1, 2, 3, 4, 5, 6, 7. Is that right? Can you even see my dots? You sort of can. I'm suspicious of this dot right here. Suspicious of that one. I'm wondering if I counted the right numbers.
What's your units on the side?
What was that supposed to be? 1.7? 1.3. Is that what it was? 1.3. And it is 1.3, so I guess it's good.
No.
Right? So this is the photoelectric effect. This is stopping potential. Right? In volts. This is frequency of the photons in terahertz, right? Of course, you know, Millikan probably had wavelength, but if we graph it with frequency, if we use frequency here, right, that means if I use this frequency light, the electrons have 0.4 electron volts of kinetic energy, and if I use a little bit more energetic light, they've got more stopping potential. Why is that? Why do they have more stopping potential with a higher frequency light? Because those photons have more energy, correct? Yeah, so as you go this way, you're increasing the energy. If you double the frequency, you double the energy per photon, right? Okay, so going this way increases photon energy linearly because this is a frequency graph, right? And that's what you're seeing here, is that it goes like that, right? Now, what we can do, there's several things we can do, but first we should put our little error bars on, shouldn't we? Yeah? And notice that the error bars are 0.2 volts, right? To be sure, Millikan's, uncertainty was far less than that. I exaggerated the error so that we could draw this thing, right? Okay, so here we go. Remember that this is the key to error bars. Get a little piece of paper, mark a point, then mark 0.2 up and 0.2 down, 0.2 up and 0.2 down. This is not so crucial because these all lie on grid lines, don't they?
Yeah, they do.
Yeah, they do.
They do.
All right. Indeed they do. I'm going to come at this guy from this side.